Hi class, this is homework help with page 135 and 136. So to start today, we are dealing with a couple proportions and some equations, and I'd like you to go ahead and read through the example. Grab my pen here. Come on. There we go. So if you look, it's reminding you about finding the slope, and you're given a couple points here. So they point out these 2 points. It's showing you that your y-intercept is at 3, and it's talking you through that your slope is up 2 and over 1 as well. So that's how they ended up with this equation. Now as you're looking at this, how's the equation y equals 2x similar to the equation y equals 2x plus 3 in the example problem, and how is it different? Well, if you notice, they both have the same slope, so you would write same slope of a rise of 2 and a run of 1. And then the difference is this one says plus 3, so that means the y-intercept is at 3, but this one doesn't have any plus anything or subtract anything. So that means that this one's going to be proportional. You could even put plus 0 there. So different y-intercepts. I'll abbreviate here. Okay. Now it's asking you to graph this equation. So again, it doesn't have any y-intercept, so we're going to start at 0, 0. It's proportional. And then we go up 2 and over 1, and continue up 2 and over 1. You could keep doing that. And then you'll go ahead and draw a nice straight line. I'll try. It's tough with this board here. There we go. And if you look, you notice that these are parallel lines, okay? So compare the graphs. They have the same slope, but different y-intercepts. I'm just abbreviating here. Does either graph represent a proportional relationship? We would say yes, that y equals 2x is proportional, because it has a constant rate of change and it goes through 0, 0. So you'd want to write both of those things. Next, what value of b makes y equals 2x plus b the same as y equals 2x? And what does that value mean? Well, if the y-intercept is 0, so if it has 0, 0, or the origin as its y-intercept, that means it's proportional. So that answers that question there. So 0 would have to be there. And you could also write it like this. That means the same thing. Okay? All right, next page. Okay, so looking at number 4, Andy uses the table below to write a linear equation. He says he can write an equation of the form y equals mx for the given values. Is he correct? And explain your reasoning. So right away, I notice that the y-intercept is at 4. So when x is 0, that's your y-intercept. However, when you have this, y equals mx, that's a proportional one, meaning there's nothing here. The table we have actually has a y-intercept of 4. So no, Andy is not correct because of the y-intercept of 4. If it said 0 and then 0 here, then he would be correct. Okay. Now we're going to solve these in slope-intercept form. So guys, what we're doing, we're getting y alone. We're trying to put it in this form. So that y stays. We're going to subtract 1 from both sides. So it zeroes out here, and I get 2x. I can put these two numbers together because neither one of them have variables. So negative 3 minus 1 more. Now that's solve for x. Or excuse me, solve for y. Now my y is on the other side, but I'm going to do the same thing. I'm still going to subtract that 1. So I get y equals, and I still have 2x minus 4. Okay. These equations would be the same. They're just written with the y either behind or in the beginning. Exactly the same thing though. Okay, on this one, we're going to get that y alone. So I need to subtract 2 first. And And I still have 2 times y, and then negative 6 minus 2 more is negative 8. And last, I need to divide 2, because right now it's being multiplied by 2, so I divide 2, and I get y equals 4 divided by 2 would be 2x's, and negative 8 divided by 2 would be negative 4. So if you look, this one is also the same when it's solved. None of them started that way, but as we solve for y, we see that they're actually all the same equation there, with a y-intercept of negative 4 and a slope of 2.